So in this video I'm going to explain to you how we can make some calculations for the microscope, specifically about magnification. So a little bit of terminology first of all. As you know, we've got two lenses on the microscope. The first one is this one here, which is called the ocular lens. Ocular because it's closest to the eye. And then this one down here is the objective lens. Now, if we have a look on each of these lenses, they've got a magnification power. So, for example, this one, it might say 10 times. And then usually we've got a number of different objective lenses with different power. So this might be 4 times, and this one might be 10 times, etc. So working out the total magnification is very, very easy. So total magnification is quite simply the ocular lens magnification times by the objective lens magnification. So in this example here, if we've got an ocular lens magnification of 10 times and we have got an objective magnification of 4 times, so we've got 10 times 4, quite simply, it means 40 times magnification. So the image or the object that we see, our specimen, is magnified 40 times. Very, very easy. And just one more. If we have a look at this one here, which we had a 10 times magnification, our ocular was still 10 times. Times by the objective, this time it's 10 times. So therefore, our overall magnification is 10 times 10 equals 100 times magnification. Now we can also calculate field of view. Now we're going to show you how to calculate field of view. So when you're looking through your microscope and you see that circle of light where your specimen is, well, that's called the field of view, and it's defined as the diameter of that circle of light seen through the microscope. Now we can calculate that in a few ways. When we're using low power, we can just simply put a ruler on the stage on the stage and have a look and actually measure the diameter of the field of view. So you grab your ruler and you put it across, just line it up so one of the divisions on the ruler, one of the lines, is right at the edge of the field of view, and you just calculate or count how many lines of the ruler go across the field of view, and then you just count them. So 1, 2, 3. So that field of view is 3 millimeters. Okay, so that's easy. Low power, use a ruler. Measure the number of divisions on your ruler, and that works out the field of view. For high power, when we're on high power, 100 times, etc., the field of view is going to be less than 1 millimeter, so we can't actually see the distance between two divisions. So we have to use a formula. And here's the formula. So we use the high power diameter, that's what we're trying to work out. HP for high diameter. And the way we're going to work that out is using this formula here. Just like always, if we've only got one thing we don't know, then we can use a formula to work it out. So let's do a scenario here. So we're working out high power diameter. Let's say our low power magnification was 40 times. So low power was 40 times. And we know that our high power magnification is 400 times. And our diameter at low power, so that's low power magnification, low power diameter was 2 millimeters. Everything we need is here now. So let's say a high power diameter, high power D equals low power magnification was 40 times divided by 400 times. Now, see how we had low power over on this side here? We want to have high power diameter by itself. So to do that, we need to times, to get rid of the denominator here, we need to times both sides by low power diameter. So that means that we're going to put our low power diameter over here. And our low power diameter was 2. So 40 divided by 400 times by 2 equals 0.2 millimeters. All right, what does that mean? It means that the diameter at high power is only 0.2 millimeters. So that means that clearly we couldn't have used our ruler because our ruler had intervals of 1 millimeter. So that is how we use that formula to calculate the diameter at high power. So the last thing I want to show you is how to calculate the size of a specimen. Now, if we know our field of view, so our field of view here was 4 millimeters, we just basically need to look at how many specimens could fit across the field of view. So with this little guy here, we need to make an estimate of how many of these we could fit across. So I reckon we could do 1, 2, 3, 4, 5. So our specimen size equals the field of view divided by the number of specimens across the diameter. So in this particular case, our field of view was 4 millimeters divided by the number of specimens, and I said I think we could fit 5 across. So that means we have got our specimen size is 0.8 millimeters. So that's pretty easy. Now, another way you could do it is you could actually, again, use a scale. So a ruler, or sometimes you can get slides, microscope slides, that have a scale on it. If you know what that scale is, so maybe every one of those is a millimeter or something, and you've got a specimen that's that big, well, it's really easy. You just need to count how many of the intervals. So that we've got 1, 2, 3, maybe 3.5. So that would be 3.5 millimeters is the size of that one. So there's a couple of ways you can calculate specimen size.